One of my favorite TV shows is called Bull. It's about a high-powered attorney who has a background in psychology. He's able to pick the best jury for his client. Well, in 2007, I sat on a mock jury trial similar to what Bull does. It was dealing with 4 young gentlemen out of North Mesquite. These young gentlemen in 1981, they developed a video game. They did this in their garage. They had plenty of equipment and they were very knowledgeable on the situation and were able to create a video game. They later went on to be very successful because they ended up creating one of the #1 all-time selling video games called Halo. Now, Halo was very successful. They had merchandise. They had their own movie. And they also had their own Mountain Dew campaign, commercial campaign. Now, these gentlemen were very successful. And as the company grew, they ended up having a problem. And that's why they ended up going to court. The problem was, how do they pay each other? By this time, they had outgrew their old plan. Their old plan was they paid each other based off of how much each person put in towards the video game. That brings us to our question of the day, our I do question of the day, TEKS 6.2D, which is, are there irrational numbers? So now let's put ourselves in the mindset of those young gentlemen and let's see how we would have paid ourselves. The question starts off, the table shows the portion of a day 4 students use to build a website. Which list shows the students in order from the greatest amount of time used to the least amount of time used? First, let's annotate. We'll use our cube strategy and we'll start off by circling our numbers. I will circle 4. Next, I will underline the question. Then, I would box in keywords. Table, portion, student. These words are very important because it tells me that the table is letting me know that I will have 4 portions based off of 4 students. I would next box in greatest and least. This lets me know that I need to order my data or my information from greatest to least. What is the question asking? The question is asking for us to order our data or our values from greatest to least. Now, the way that we do that is, step 1, we'll convert all rational numbers to decimals. Step 2, we will plot values on a number line that includes positive and negative rational numbers. Step 3, mark each answer choice true or false based on the values being ordered greatest to least. Let's start with step 1. Convert all rational numbers to decimals. We start off with 29.4%. Here we're dealing with a percent to a decimal. When we move the decimal point 2 places to the left, that's when we will convert our percent to a decimal. Now, in certain cases, you might need to add a 0 in front of your answer to make it correct. Let me give you an example of decimals to percents and percents to decimals. All right, this visual shows us going from a decimal, moving from a decimal to a percent. They moved their decimal place 2 places to the right to make that decimal a percent. Well, our question is asking us to convert a percent to a decimal. So we will move our decimal place 2 places to the left. You should end up with 294 thousandths. Next, we have 37.6%. We have the same rule, percent to decimal. We'll move the decimal point 2 places to the left. And when we look at our visual, we simply know that all we're going to do is just move it 2 places to the left from where the decimal is at. This will give us 376 thousandths. Next, we have a fraction to a decimal. We'll convert mixed numbers to improper fractions, and then we'll divide by putting the top dog in the house and the bottom dog on the outside. Now, what I mean by top dog and bottom dog? Fraction to decimal, we'll divide the numerator by the denominator. The little dog is in the house, the big dog is outside. When we do this, we would end up with 27 being divided by 25. We would move our decimal up, get rid of it. So now we're basically looking at 70 being divided by 25. 25 goes into 72 times. We will be left with 2. We bring down our 0. We'll have 200. And when we have 200, our answer should end up as 28 hundredths, okay? So, without all of that clutter that I had on that last problem, now you can see it a little bit clearer. Our answer would simply be 2800. But please make sure that you remember how to convert fractions into decimals. Next, we have a fraction to a decimal, but this time we should be able to recognize 3/10 because it's a common fraction, and we should be able to convert it very easily. 3/10 should be equivalent to 30%, and 30% should be equivalent to 3/10. Evaluating using number line. We can evaluate our values using different type of number lines. We can use a vertical number line that has positive and negative integers. We can use horizontal number lines. Now, the biggest thing I want you to take from this part of the lesson is that we can have multiple values that are equivalent. Take, for instance, we can have 1 is equivalent to 7/7. 2 is equivalent to 14/7. 3 is equivalent to 21/7. So, I also want you to understand, if we look at the vertical line or the vertical number line, horizontal number line on top, 1/10 is equivalent to 1/10. 2/10 is equivalent to 2/10. 3/10 is equivalent to 3/10. Now, when we think about this, if we think about it as money, if I say you have 2/10, you know that you have 2 dimes, that's 20 cents or 20%, okay? 20% of $1. So this is how we read data and values on number lines. Let's get back to the lesson. This is our table and this is our information that we'll be plotting. When we look at the data or the values, we notice that our values are only between 20% and 40%, assuming. Now, let's plot our first information or our first value, which is 29.4%. and it will be located slightly in front of 30%. Our next value is 37.6%, and it will be closer to 4/10. Our next value is 7 over 25, which is equivalent to 28% or 28 hundredths, and it would be located slightly behind 29.4%. Our last value is 3/10, which is equivalent to 30%. So once again, we need to be able to read information fluently. So don't forget that 3/10 is equivalent to 30%, and 30% is equivalent to 3 over 10. 7/10 is equivalent to 7%, 70%, and 70% is equivalent to 7 over 10. Just know that these values are all equivalent. Now let's list our information from greatest to least. We'll start out from least and work our way up. Here's our data. So we know that 2800 is our least. 29.4% is the next to least. Then second to greatest is 3/10 or 30%. And our greatest value is 37.6%. Now, we need to put the corresponding name with the corresponding value. Ernesto will represent 28%, our least value. Jamel will represent next to least at 29.4%. Blake will represent next to the greatest at 30%. And Andrew represents the greatest value at 37.6. Now let's look at our answer choices. J, we have Andrew, Jamel, Ernesto, and Blake. Well, when we look at our data, let's compare J to what our data says. And it will be false because our table tells us that Ernesto had the least amount. Let's go to H. Ernesto, Blake, Andrew, and Jamel. Our answer will be false once again because Ernesto is the least, and H is showing Ernesto as the greatest. Let's try G. G will be false because Andrew is the greatest. And F. F is true because it is listing all of the values from greatest to least. Thank you, y'all. I'll see you at the next lesson. Sorry about this one being so long. Have a great day.